So, harmonic series we know very well. This is 1 plus 1 over 2 plus 1 over 3 and so on. This diverges to positive infinity. So this thing we know very well. How about this? Minus 1 raised to power n divided by n. Or let us keep it this. And this would be 1 minus 1 over 2 plus 1 over 3 minus 1 over 4 and so on. So how about this? Harmonic series given in the top diverges to positive infinity. But what about this?
We have make the partially sum.
क्यों partially क्यों partial sum अगर convert करते हैं.
There's a criteria, but we can apply some tests as well to find out whether this particular series converges or not.
1/n जगह नहीं कि bn खणी या कुछ भी करे इन्हें या देखने converge करे थी तो और आगे समझ में आता है converge कर otherwise
It means comparison test. We can do, but basically this converges. This particular series converges. This is called an alternating series, with one term positive, another negative, then positive, then negative, and so on. We call this alternating series. And now we have an alternating series test which will tell us that whether it will converge or not. So it is called alternating series test or Leibniz criterion or Leibniz test. So alternating series test, also called Leibniz test. So what does it say? We have a sequence that is convergent. AK is a sequence, it's not a series. Be convergent and what is the limit? The limit of this sequence AK is going to be 0, and another condition is AK is monotonically decreasing. Then what happens? Then if you take this particular series when let's say k runs from 1 to infinity minus 1 raised to k, AK is convergent. So this is what we call alternating series test or Leibniz test. You have a sequence AK, let's say that is 1 over k. We know very well it is convergent. This sequence is convergent 1 over k. The limit of this sequence is 0 and this sequence is monotonically decreasing. Okay, these two criteria are satisfied. Then if you take your sequence and you just alternate the terms between negative, positive and so on, and you take the infinite sum, this converges. It means I don't know whether this converges or not. This one, whether it converges or not, but I give it minus 1 raised to k, it will always converge according to alternating series test or Leibniz test. So harmonic series, I don't know whether it will converge or not, but if I alternate the terms with positive and negative, this will always converge with this test. And the test said that if you take the sequence with the limit 0, the limit must be 0 and it should be monotonically decreasing, not increasing. You know very well 1 over k is monotonically decreasing. 1, 1 upon 2 and so on. And what is the condition for monotonically decreasing?
Every next one is less than.
Less than or equal to
First one.
the next term
Is
is
less
smaller than or equal to the
than
previous term. So this is what we call alternating series test.
Yes.
And if this criteria is satisfied, we say that this particular series is convergent. This does not imply that this converges. 1 over k. If this converges, this does not imply that this converges.
This converges.
This thing should be okay. And let's say if this thing converges, if this thing converges, then it obviously implies that
One or k.
this will converge as well.
As well.
This converges, so alternating series will converge. If alternating series converges, this does not imply that the original series will converge as well.
Yes.
You can check the relationship.
सर थोड़ो विचार दियो
जी।
लिमिट अगर है हाँ जी 1 और हार्मोनिक सीरीज अगर उन्हें लिमिट एग्जिस्ट करे थी 0 ते 0 ने अप्रोच करे तो कन्वर्जन आएगा
Limit चाची क्या होता है क्या मसाला? Limit of a sequence.
सीक्वेंस
This is the general term of a sequence, but when the same thing is kept inside a series,
अच्छा पार्शियल समझेंगे ना
yes, then this limit is not 0.
सर
The limit of this one is 0. This limit is not 0.
और इन्हें उलट पॉसिबल थी तो ट्रू कन्वर्ज करेंगे तो लिमिट जरूर होगा सर
Yes, last one. Established true. So the next idea is, what do you mean by absolute convergence of a series? So it's a definition that this sequence AK is called absolutely convergent if what happens, if this is convergent, the absolute value of all the terms, then they are added, is convergent. So what do you mean by this? A sequence is called absolutely convergent if we take the absolute value of all the terms, then we just add them, this is going to be convergent. For example, we have this. Is this convergent? Is this convergent or not? By the
By previous.
Lebanese test,
Lebanese
it's
convergent.
convergent. Now this is my this. Now you have to check that whether this thing converges or not. It means you take the absolute value of every term, then you sum. What is the absolute value of every term?
पॉजिटिव
It means you take absolute value and simply you can ignore minus 1 to the k.
Yes.
Because minus 1 to the k gives you positive and negative, so you have this
1 over
1 over k. This converges?
no
This is not convergent. So we call this original sequence to be not
Not convergent.
absolutely.
Absolutely.
This is convergent. We know very well.
Yes.
But this is not absolutely
Absolutely
convergent.
convergent.
It's the idea. This is convergent, but this is
Absolutely.
not absolutely convergent.
converge is true
Yes. How about this? Does this converge? So it converges by Lebanese test
Yes.
because the 1 over k square goes to 0 is k goes to infinity, and it's monotonically decreasing, hence it is convergent.
Yes, sir.
Take the absolute values, then you will get this 1 over k square. This is convergent.
Yes.
This is also convergent. So we call this particular sequence that this is absolutely
Absolutely convergent.
convergent. Absolutely convergent. So what is the relationship between absolute convergence and convergence? What is the relationship if we want to build with the help of these two examples?
एब्सोल्यूट होती कन्वर्ट जरूर होगी
So if a sequence is absolutely convergent, it will be convergent. So this sequence is absolutely convergent. Then this is convergent as well. This sequence is not absolutely convergent. It means, what can we say about this?
may or may not sir
May or may not. It may or
may not
converge. May or may not converge. Okay. So this is how we discuss absolute convergence and convergence. There is another property that we always use that we should know, at least, that if you take this sequence and take its absolute value, it means you evaluate this sum,
Yes.
then take absolute value. It is always less than or equal to, you take the absolute value of every term and then you take their sum. This is the relation that is always satisfied.
Yes, sir.
And it must be true always. Now, you know very well, if this particular thing converges, then this will obviously converge. When this is convergent, this is called the terms in absolute value. When this thing is finite, obviously the smaller thing will be finite as well.
Right as well.
The question is why this relationship is true. Always. In the sense of infinity, as well as in the sense of finite sum. It means from 1 to capital N, let's say. If I take the sum of only two terms, let's say,
Yes, sir.
and sum of k is equal to 1 to 2, this becomes a1 plus a2 is less than or equal to mod of a1. What is this called? Is this triangle inequality or something like that?
No, I think the parallelogram equality.
I think triangle inequality.
Somehow, unless or
It's
equal.
triangle inequality. So this is absolute value of the sum. This is sum of the absolute values. We call this triangle inequality. We can apply the principle of induction to extend this 2 to some fixed n,
Yes, sir.
and then since these things are good and linear and something like that, we can apply limit and then we can convert that n to infinity. So to prove this idea, the first thing you have to do is you have to prove by induction
Reduction.
from 1 to capital N. Once you are done, then you have to apply the limit. So this property is always true in this sense. We can call this thing to be triangle inequality, but triangle inequality in infinite terms. And this thing will lead us to, you know very well that sum always represents or gives us another idea of integral.
summation
Yes, sir.
So this integral in the absolute value is always less than or equal to the absolute value of the function then integrated over some interval.
Yes, sir.
So this is always true. And maybe we'll do this in Riemann integral as well. Let us write two different criteria for checking convergence or divergence. We may call them comparison tests as well. That we are given two sequences or two series, we are going to compare them. We are given two series and we are going to compare the series. We may call these comparison tests. Number one, so given AK, summation K runs from 1 to infinity, and let's say BK such that this BK is greater than or equal to 0 and is, it means this is convergent. This is convergent and each and every term in AK is less than or equal to BK in the sense of absolute value. For all K. Then what happens? Then this AK
will also
is also convergent. This is what we call comparison test. This is one of the comparison tests. But we may call it absolutely convergent as well, because we have checked convergence in this way. If something is absolutely convergent, obviously that series will be convergent. So it means, what do I want to say? That this is convergent and each and every term of AK is less than or equal to BK in the sense of absolute value. Now you sum this and you sum this. If let's say this term is finite and fixed, then this will also be a fixed sum, hence we call this thing to be convergent. Like this is the smaller sequence, this is a smaller series and this is the bigger series. If the bigger one converges, the smaller one will also converge. And we can make the reverse idea as well. If the smaller one converges, how about bigger one?
May or may not.
May or may not.
Yeah.
If the smaller one diverges, then the bigger one will also diverge. That is another test. And you can reformulate this one. If your smaller sequence or smaller series diverges, then the bigger one will obviously diverge. But if smaller one converges, we cannot say anything about the larger one. It may converge or it may not converge. What's an example?
वो पुराना है रोड मापे सको था सर्वे मापे
हाँ सही इतने बड़ी बात करना है भाई इतने रोड है सही क्या है
सही रोड से जो ताम मापे सको था तो मतलब सर्वे मापे था सको तो जरूर नहीं रोड ही मापे सको सिमुला के तीनों
इतने मना बिन चेंज कंपैरिजन like you compare road from Sakkar to Khairpur and Peralo to Khairpur. बाबा सक्कर का खैरपुर ताई ऐं सक्कर का प्रेलो का खैरपुर ताई जो रोड आहे वो सक्कर का खैरपुर ताई घटि आहे जेकॾहिं सक्कर का खैरपुर ताई आहे 25 किलोमीटर त प्रेले का खैरपुर 5 किलोमीटर खां घटि हूंदो छाकाणि उहा शइ असां ऑलरेडी चई छॾियो आहे त हिन खां घटि आहे so this is same as that. So my comparison have been different paths so there have been different series the comparison now. So the example is this: k equals 1 to infinity 1 over k equals 1 to infinity 1 over k square. Which one is smaller?
Second.
Is it smaller?
Yes.
This is bigger.
Yes, sir.
Smaller converge. This. Larger one will converge. May or may not. So you can see smaller one converges. The larger one does not converge.
Not converging.
But if let me give you another example. These two. 1 over k. 1 over square root of k. Which one is smaller?
First one. Second.
Smaller.
Second.
This smaller diverges. This diverges, obviously.
Yes, sir.
Then this diverges as well.
Diverges, yeah.
If your smaller series diverges, the larger one will diverge as well. This diverges, we know very well.
Yes, sir.
Then this will diverge as well.
Also diverge.
Okay, this is what we call some tests for the convergence. We have another test, what we call the, I think, ratio test and root test. Let me write those and discuss a few examples. Then maybe we are going to end it. And we'll discuss what to do next in the next class. It will take just 5 to 10 minutes, I think. So, ratio test and root test to check the convergence or divergence of a series. So, what's the ratio test? We can discuss these things in detail, but if you know the superficial things, it is okay for us.
Comparison between two sequences or series.
So, given this, let's say n equals 1 to infinity n. Whenever I'm writing n equals 1 to infinity, I will write n. When I write k is equal to 1 to infinity, I write something like ak. So this is ak. That's it. So, and let's say L is defined as this. Lim sup. I can define limit, but you can define lim sup as well. If you just say limit, that's okay. Lim sup, n goes to infinity of this particular thing. N plus 1 divided by n. So you take n plus 1, n, and take their ratio and find their limit, and you name this guy to be L. When this limit is what? Less than 1, then series converges. Are you okay with this?
Yes, sir.
L is greater than 1, then series diverges, and third is L equals 1.
Yes, fair.
What do you mean by this?
We are not sure about whether
It may converge or may not, but this particular method will not help us. We should go to some other methods. Are you okay with this? Because I don't have in these notes, then I have to check from somewhere else. It means, are you okay with this? Greater than 1 or less than 1?
sure.
Sure. Okay.
Then we are in BSc.
How about root test?
Taking power 1 over 2, 1 over n.
Lim sup n plus 1 converges. Okay, yes. And root test is, you are given the same thing. You define L to be, you take an in the sense of absolute value always. Otherwise you can't find its nth root, it would be problematic.
Yes, sir.
You find its nth root and you take limit as n goes to infinity. I told you can take limit or you can take lim sup, there is no problem.
Yes, sir.
So if this L is less than 1, what happens? Greater than 1, what happens? And when L equals 1, test fails. Same thing? Same thing, copy or something like else, something else. I think it's same thing. Yes, less than 1 converges. So less than 1 series converges, and here series diverges. Where these are some sort of good tests to apply. When your series contains some sort of factorials, you can apply this thing. It would be very much good to deal with those. And when your series contains some sort of power n, then you can apply root test. It will be very much good to give you some good results. So it's very easy, just apply this and find the limit and then check what happens. It's very easy to apply these tests. Okay, so if we just do the course of real analysis in this way, it will take us 3 to 4 weeks to complete. Speaking sincerely. But thanks for taking very and let's see, we are going to